Hello everyone, it's Sean and welcome back to Having Fun Repairs. We are continuing our restoration on the Triplett volt ohm meter, and as you could probably already tell, I've done a little bit of work leading up to this video already, and by a little bit, actually quite a bit of work, to be honest. So I kind of want to go over what went into restoring and repainting this case, and like I said, it's not perfect. There's a bit of runs and everything in here, but as far as the case is concerned as a whole, I think it's turned out rather okay, given what I had to work with and what I did. So what I would like to do is just kind of cover a few pictures with you. And I'll put them somewhere up in a corner somewhere. But, you know, to start off with, the case as we left off needed a lot of additional work, a lot of sanding. So I went ahead and bought myself some wire brushes, wheels that I could attach to my electric drill and start getting off the rest of the paint. And for the most part, a lot of the excess rust as well. And those wire brushes ended up polishing up quite a bit, polishing this up pretty well per se. However, you know, as I was working on this and the more I worked on it, I realized, you know, either this was never galvanized still, you know, it's pretty heavy. Maybe it's aluminum. I don't think it is though. I think this is just all, you know, a thin piece of sheet metal. I don't believe it to be galvanized, but because it would start to rust after some time away from it, even after sanding it and getting rid of rust. And then again, you know, if it had a galvanized surface, you know, by sanding it, you're essentially getting rid of that superficial or sacrificial layer on top anyway. So you expose it to the element, it's going to rust. But we are able to polish it up quite a bit, and I even, you know, put a little bit of my sweat, tears, and blood into this as well, doing a couple unsafe practices with the drill. But you know, I worked my way around the entire case with the back, the bottom, the sides, the insides as well, and you know, just uncovered and got rid of as much paint as possible, continuing to try and polish it up as much as possible, and essentially got it to where it was a workable surface, you know, trying to get it ready for paint and prep, etc. The hardest part was working on the inside, to be honest anyways. There was a lot of corrosion down here at the bottom, and as you can see that, you know, the filler we have in here, actually there's no filler in here whatsoever, but what remains is still, you know, not a perfect surface, but it's not a surface in which rust is still there. So, you know, after doing the wire wheel and polishing this up a bit, you know, working to abate as much rust as possible, while I was starting to work on it, I started thinking, well, what do I do moving into the future? Well, you know, there are rust prevention compounds and rust removal compounds you could buy commercially and stuff, but I also was giving consideration to the paint scheme as well. Like, will I go to like that army or military green? Will I take this back to black, which obviously you can see the choice that I made here. And do I want all the surfaces painted, or do I want to leave some things? And ultimately I decided, you know, given the fact that I like this hinge, this latching mechanism, I really like this initial stamping on here, made in USA as written on it. I thought that was rather unique, so I wanted to try to preserve this as much as possible. So I ended up not painting it, although I did get a clear coat onto it. So also, you know, didn't want to paint this surface either. This is where the original battery would have been held. In this video, we still have to address the battery side of things, because you do need a battery, right? We worked on the rectifier in the previous video. But again, a lot of rust down here, and that's where a lot of my focus went into. So I got a bit of Rust-Oleum rust dissolver, and this is where the days actually came into play. And we're talking multiple days applying this product, letting it sit for the duration that it originally said, cleaning it out, you know, applying more product, having it sit longer. You know, the rust that was down here was very hard to mitigate, to abate, to get rid of. But over the span of a few days, it started to get better and started to remove more. Eventually, I got out the Dremel and went down into there to kind of rough up the surface some more and sprayed some more to get rid of more rust. You know, the entire purpose was, you know, to abate or mitigate as much as the current rust that was on there as possible, so that way we have a surface in which we can actually work with and prep to ensure that you know, the metal is not going to just corrode through beyond this point. So I was able to abate it with that cleaning compound and using the Rust-Oleum and you know, the wire wheel and my Dremel to get into some surfaces. But then I had to address, well, how do I prevent rust again? So I bought a product, basically a rust converter made by Rust-Oleum. It's a spray-on product that's actually in a matte black finish, and essentially sprayed, masked off the parts I didn't want painted. And again, like I said, nothing on here is entirely perfect. But you know, got that rust converter down and applied several layers of it. And then once I finished up with that, allowing it to dry for a little bit, I decided to clear coat it as well, give it a nice clear coat, just to give it a little bit of shine. And again, like I said, you know, it's not perfect. Could I spend a lot more days on this and have a highly polished product? You know, absolutely. But that wasn't really my intent going into this, to have something extremely pristine as if it was bought off the shelf day one. You know, I just wanted this to be better than what it was and to abate as much rust as possible so it's not problematic going into the future. So this is the case. It's taken care of. Again, not perfect, but I'm rather pleased with it. And it will serve its purpose. Again, between the rust converter, the paint, the clear coat that's on it, I don't foresee any immediate issues going into the future. Which brings us to what's next? Well, there we have it. I ended up picking up essentially some battery packs off of the Amazon. Basically a case that's going to allow me to put in, can I get this open? It's got an on-off switch on it too. Hey, there we go. 3 AA batteries of 1.5 volts. If you remember, the supply that was internal to this was a 4.5 volt battery. We're talking lower milliamp hours with these AA batteries. I'm slightly concerned that there won't be enough current for this, you know, produced by this supply with these AA batteries. But, you know, so maybe it won't last as long or something, but, you know, it's a bit of experimentation here. So, you know, yeah, using this thing, we'll eventually find out if it's going to serve our purpose. If not, it's going to be back to the drawing board, but that's the initial plan I have, is to use some AA batteries to rebuild that power supply, or the battery supply for it. But then we have our actual voltmeter here. Everything's still labeled up. We've got all of our placards taken care of, plus, you know, all the cleaning that we did on this. We need to get these wired back into here, which means going back over my notes, stripping these wires back a bit, soldering back to their terminal boards. You know, getting all these things buttoned up, so our screws and everything, getting all those back in, and you know, getting this put back together. As far as the leads are concerned, you know, I have tested these leads, and despite the fact that they don't look to be in the best shape, they are functional. I'm probably not going to really address these in the video. Not sure what to do with them anyways, because this isn't really a standard lead plug anymore. I'll probably pull the tape back off of this just to see why it's taped up. Maybe make that look a little bit prettier. But that's going to be about it for the leads. Not going to do too much to them. I'm just going to primarily keep them the way they are, which is maybe a bit disappointing for y'all, but you know, it is what it is. The main goal, like I said, in this restoration is to have a working multimeter, albeit, you know, because we had to substitute out some values, not exact values, but within the tolerance of the previous ones on these placards. My hope is that you know, under test, our meter is not too far off. And then, like I said, with the rectifier, since we did away with the selenium rectifier and we went with some diodes, you know, traditional silicon diodes, that we don't have to add additional resistance in here, because these diodes are more efficient. There's going to be less current drop across them as there would be with the selenium rectifier. So we may have to add in some additional resistance. We'll see what happens. We'll see how it plays. I have to test it out. That test piece will obviously be something that we demonstrate. Here goes our leads for our battery pack. So we'll see how it goes. But you know, from here it's really just buttoning everything up, soldering these terminal posts, getting the screws back into this, getting this back into the case, and then you know, testing. And testing is usually when you find the issues. Once you think you have something functional, and you know, hopefully there's no issues, but if there are issues, we will have to address them. So in a nutshell, that's kind of like the game plan moving forward. I've covered the case. We're going to start soldering it back in these placards. We're going to attach our battery pack, and we're going to test this thing using the leads that came with it. Alright, well, rather than recording an entire section of me just soldering wires to termination points on these placards, the terminal posts, figured I'd just demonstrate one for you, and then cut out the video and then come back once it's done. Primarily because, you know, this is going to be rather time consuming. I can't see myself sitting here for 2 or 3 hours straight recording, you know, me soldering wires and then having to speed through all of the nonsense, and you're not going to get anything out of that, to be honest. That, and you know, it takes away time, my ability to get up and go around and do some other things and take a break, etc. It's just not worth it. So that being said, I'll demonstrate one, although I went ahead and do have one wire already soldered in, and that's because I thought a minute ago I was recording and explaining this, but I actually hadn't pressed the record button on OBS Studio. So yeah, now we're just going to demonstrate this time, hopefully the appropriate way. So what I've done is, and this might be a term that might be familiar to some of you, others of you it might not be a term that you're used to, is I've went ahead and that one's sticker's starting to come off. Don't want that to happen. What I've went ahead and done is I've fanned out the wires that I need for, you know, soldering to the upper part of this first placard in the termination points. And what do I mean by fanned out? Well, for those of you who've ever terminated Cat 5, Cat 6 cables to their RJ45 connector, you know exactly what I'm talking about here. You essentially take your stranded wire, you put them in the correct color code, right, the correct order, you get all your wires right beside each other like my fingers are just now, and you get yourself a pair of snips or diagonal cutters or flush cutters, whatever you want to call them, and you cut all your wires flush. Obviously I'm not going to cut my fingers flush. And then you feed them into your RJ45 connector, and then you crimp that connector down onto the wires. You know, that's what I mean by fanning them out. In this application, it really just means getting them in the appropriate order, right, to ease the work that I need to do. And for the most part, because these are a solid core conductor, you know, straightening out the wire as much as possible so there's no kinks or bends into it. because you're dealing with a very limited length of wire to work with, okay? So I wouldn't want to strip these all the way back or have to cut down the wire too much because I only have the length that I have. So and to enable myself some mobility with the part while I'm working on it, you know, I want to get these in an appropriate order, and I want to get them straightened out so that way when I terminate them, you know, I've still got some mobility with the placard here, right? So that's essentially what I mean by fanning out my wires, okay? At least in this application. So our second wire here, I've already, you know, it was labeled during video 2 in the series. Fortunately, I was smart enough to think ahead and label all my wires and take plenty of pictures so I can actually verify with my labels. You know, I like to be as thorough as possible so I'm not making a mistake going into the future. I've made plenty of mistakes. Actually, a video you'll see actually is coming out before this video ever will. In the video on the Motorola radio restoration, I got some vacuum tubes swapped into the wrong spot because I just wasn't paying close enough attention and burned out the output power tube. So just what it is. Silly mistakes happen when you're not paying attention to detail, and attention to detail is necessary in a lot of this type of work. But moving on, you know, there's two ways that you can strip back the wire. You can use something like your flush cuts or whatever to try to strip it back. I typically try to stay away from these because I don't want to nick the actual conductor, okay, my wire, put a nick in it. But if I have to, you know, I will use these. Barring some of these are not that long, I will most definitely have to use these to strip back some outer insulation. What I am going to try to use for as much as possible is this little tool right here, made by Klein Tools. It's a wire cutter. It's a rather unique one. Essentially, you feed a wire into this side, and this comes down and clamps and holds the wire in place. You got different gauges on this side, so you know if your wire is you know, say 10 AWG, 12 AWG, you know what size to put it in order to strip that outer insulation. It's all labeled up here. It's easy to read, etc. And essentially the wire comes in, and then the teeth come down, the actual cutting portion, and they go bite into that insulation minus the actual wire because of the gap, and then it just separates the two just like that. And you know, rather useful tool, bought it online. There's also a cutter right here for those of you familiar with cutting mechanisms as such. When I look at it, it kind of reminds me of like a cigar cutter like you see in the movies with the Cuban gangster or whatever, or the Italian mob boss who grabs a cigar cutter and cuts the end of his cigar. That's what that reminds me of. But anyway, it's got a nice little cutter on it as well. So let's see, this is BT2 as I've fanned it out to be, and essentially going to because I've already done one, I know that I am not here at what is this, 16 or 18, I can't remember. I'm actually at the smallest opening all the way over here on the right. So I'm just going to feed my insulation, my wire into here, and I'm going to choke up on it a bit because I only want to expose as close to possible the outer portion. Just right in here, you can see not much has been fed through. Hopefully you can see that. And then I'm just going to go ahead and strip it, and there we go. Easy as pie. Of course, this insulation is old and kind of turns into a little bit of dust, but it's holding up okay. And it's stripped, and I don't have a whole lot of wire here, and I still got plenty of room to manipulate it and get it through this terminal hole here, this through hole post. And then we're going to pre-tin our wire and then solder it to the board. You know, common practice is if you got a soldering iron on and sitting close by, don't just turn it on and let it sit. You know, put some solder on it. You don't want to burn out your tips per se. Putting some solder on it helps protect it from oxidizing. You can always use something to clean it off with prior to use, but saves your soldering iron tip. Put a little bit of solder on it. while, you know, in its thing warming up, and leave some soldering on it. Going to use a little bit of paste flux. This is an old jar that I've had for many years. It's taken me very long to get rid of. And by what I mean by many years is I absolutely mean many years. It's been over a decade since I've had that. Okay, so put a little bit of solder onto my soldering tip. Going to on one side of this wire add the soldering tip, and then on the other side feed in some solder. You can see just like that it's tinned. Sometimes you'll see me take the shortcut and just put solder onto my soldering iron tip and, you know, run this up and down the wire. You know, it's not the most appropriate method. It does work, but you know, traditionally when I taught advanced soldering techniques at a schoolhouse, by the guide I was going by, set to a certain standard, you don't paint solder onto a wire. Okay, it's not the appropriate method. But you know, you do you, and you do what is easiest for you. It's all about developing techniques that work and techniques that are going to remain functional. Okay, so the main thing I want to say here is solder goes, or solder flows where solder goes, right? We pre-tin our wire so there's solder on there. Okay, so when I go to terminate our termination point here, or on our terminal board or PCB or placard or whatever you want to call it with the wire, when I want to go to make this mechanical connection through the application of solder, there needs to be solder already on there, because that's going to help with it flowing to where it needs to go. That's essentially what I mean by that. That's really all that I mean by that. So that when you pre-tin things, it typically makes your life a lot easier. It allows for your work to go quicker without having to wait and just constantly applying heat, enough heat for something to heat up. So what I'm doing now is just putting the soldering iron to one side of the terminal post, my solder to the other side, and then don't want to push the wire out. That's not appropriate. But I'm going to let my soldering iron with the tad bit of solder on it heat up the post, and on the other side feed solder, and then like I said, solder's going to flow where solder goes. So that's pretty quick and easy. Then I'm not going to touch it. You've heard me say this in several videos. There is a eutectic state of lead tin based alloy solder. You know, it's a very short one. It's not very long, which is good, which is why lead based solder is primarily used over your silver solders in a lot of applications. And what I mean by that is, you know, it doesn't just go from a solid to a liquid state. There is a plastic state, that eutectic state. Okay, and during that cool off time where it's more plasticky than liquid, if you move around your wire or whatever you're soldering, you can actually cause it to form hairline fractures within the solder, and then that is not going to be a great mechanical connection once the solder fully becomes a solid again. There will be hairline fractures in it. So you leave it alone. You let it cool off. You let it go from the liquid state to the solid state before you start moving things around. Essentially, the eutectic span, or I guess you could say, for lead tin based solder is very minimal, so it doesn't stay in that plastic state very long, unlike other solders. So that's one of the reasons why it's used. Also, you know, just the alloy itself is more conducive to electronics, even though it does present the hazards that your non-lead based solders do present concerning health. It just is what it is. You look at your trade-offs, and so long as you're not chewing on this and eating on this, I think you're pretty okay. Generally speaking, I also have my solder extractor going, so that way it's sucking out the fumes away from my face. But for the demonstration purposes, I needed to turn it off so you could hear me talk. That being said, that's basically all there is, and I'm going to have to repeat this process for all the remaining wires, and you know, that's my plan, and I'll come back to this once it's finished, and we can move from there. Okay, I've got it back together good enough that we can begin to run a test on it and see how it performs with all new, not all new components, but with all the bad components that were way outside of a 10% tolerance, even including a lot of these 5% tolerance. We try to get it underneath that. Replaced, and the cleanup and everything, we can run a test to see how it performs and see if there are any other issues. So what I've done for now is we'll check the DC as what we did in our previous video. I've set it to the 5-volt scale. Now I don't need the battery pack right now, but we'll just we'll leave that off for a second because we're just doing a DC measurement. So if we're not checking resistance, I shouldn't need the battery. Okay, and what I'm going to do is take our leads, I'm connecting our ground lead. All right, let me turn on this power supply. Increase limit for our current, and we're going to get our voltage up to, we'll just take it to 0.2 volts. All right, I'll now take and connect the ground lead. Again, we're on the DC volt scale at 5 volts. Hook in the positive lead and connect that positive probe. And because we're on the 5-volt scale, it should be this bottom one right here, and we should see it increase. Well, we're getting anything. It's not a good sign. At 1 volt, I'm not seeing it. Are my probes connected good enough? Guess it wasn't. There we go. Oh, I'm at 5 volts, but I'm not showing 5 volts on our 5-volt scale. I'm showing about 5 volts on our 15-volt scale. This doesn't make sense to me. I think we're having an issue here. All right, so I've spent a little bit of time looking over some things. I found something that was rather interesting. Okay, so we can see our contacts. I've zoomed in a bit right here. Right, this is the one that's going to hit these points down here. And when I roll this over, and I'll lift it up just a tad bit, hopefully you can see this. You can see that this one and this one is aligned, and a bit harder to see, but the one down in here, they're all aligned at the same point. So directly across this rotary switch, they're all in alignment, with exception of this one right down here. This one is advanced by 1 segment on our rotary switch. Tells me that it's potentially slipped. I wonder if we can push it back a bit. Will it move? And yes, it does. It 100% moves, which it shouldn't do that. And I can push it back over the previous one, but it won't go beyond the previous point, so it's move it. It doesn't really snap into place with the other ones, but okay, I've at least got it in alignment right now with the other 3 contact points, and it's on the 5. So let's see if that was it. And if it was, then I'm going to take this rotary switch apart and address that issue, which no big deal, to be honest. For me, I didn't want to have to take apart the rotary switch, and I won't have to take it apart too much. But if that is the issue, it's going to Might tell us a bit of a more to the story of why this thing, why all those resistors were well outside of their tolerance. So let me turn this on first. Okay. I'll hook it up. And what happens this time as we increase our voltage? Whoa, well, that's a lot more responsive. I'm at 1 volt. And I'm at 1 volt on our 5 volt scale now, so that's aligned. That's 2 volts. Okay. Reading about 2 volts. All right, so I've shown 3 volts here. I'm a little bit below 3 volts here. Let me go to, why don't we hook up our digital multimeter at the same time and we can compare that value. But it looks like the rotary switch was an issue as well. My digital multimeter is showing, see if we can get rid of this glare for a second. 3.019. Now I'm below 3 on this. But just a smidge. Let's go up to 4. Let's go up to 5. I'm wondering if that's something to do with this one lead right here not being that good. See, it's jumping all over the place. But yeah, actually this and this they match, but we're a little bit below here. Otherwise, we're actually getting relatively decent measurement. Just switch to the 15 volt scale, so that's put us up here. We're actually reading a tad bit high on the 15 volt scale. Yeah, this lead is going to have to be, or at least this connector right here is going to have to be addressed. Maybe it was just sticking. Now we're reading low. Let's get up to 10 volts. Why am I not jumping up to 10? Is that the rotary issue with the rotary switch? Might be that rotary switch. Might be that rotary switch. So, well, I'll tell you what. We'll kill this test for now. I'll get that rotary switch apart and we'll see if we can address what's going on with it. Alright, I've done my best with the disassembly, and hopefully I haven't made too much of an issue for myself with reassembly. It's not going to be easy, I can guarantee you that. But went ahead and took care of more of the oxidation on our contact points upon reassembly. But we should easily be able to see what is caused the failure in here. As a matter of fact, I'll demonstrate it. Actually, let me make sure I'm holding the bottom so the post doesn't twist. So you see that? Can you see how this center piece is just moving? Now mind you, this post right here is not turning as what would happen if I twisted or turned the rotary switch itself. So what has occurred is our actual I don't know what kind of material this is, but this plate has worn loose over time. So perhaps what I'm going to do is I'm going to make all these facing this direction. Perhaps with a tad bit of super glue or something, we can keep this from rotating freely, keep it aligned. So what I'm going to do for now, get this in. So I'm going to rotate these directly towards myself like that. Then align this one right here. So it's in line with the bottom one. And when we insert the tops, we can keep them all in line. And I am going to apply an epoxy around here. Hopefully allow this to stay in contact. I think the first thing I'll do is I'll just get a little bit of super glue down in there, because that will provide the initial strength for it. Let that glue set up for a bit, then I'm probably going to put either a 2-part JB weld down on it as well, or a second type of epoxy. Either from Permatex 1 minute or some E6000 or B7000. Not too sure yet. I'll figure it out. But once the epoxy's set, I will get this back together, hopefully without too much difficulty, and we can go for round 2 testing. All right, got it back together. Wasn't as hard as I was thinking it was going to be. Definitely wasn't as easy as I was hoping it would be. But we'll go through and just check out the metrology of this a little bit. I've got my digital multimeter hooked up and the analog volt meter hooked up. We will begin to increase the power supply output. So right now I'm holding close to 1 volt, and we are seeing essentially 1 volt across both multimeters. Let's go up to 2. Alright, so almost at the 2 volt threshold. So we're essentially at 2 volts now. Seeing about 1.9 on our scale here. So we're off by 0.1 essentially, but that's not too far off. That's pretty close. Now, this could be either because I need to get the contacts cleaned up a little bit better. That's going to affect the measurement, or it could be because of the resistors that we chose that were not the exact value of the original ones, but were within the tolerance. That's going to affect what's displayed up on our glass here. That could affect the measurement. So we're going to increase now up to 3 volts DC. and at essentially 3 volts. I'm showing 3 volts on the digital multimeter. And 2.8 on our analog. Why don't we go up to 4 volts? All right, we're essentially at 4 volts on the digital. It's showing a slightly over 3.8 on our analog. Let's get up to 5. All right. 5 are a bit further out. About 4.7 on the analog, 5 volts here. So it looks like we lose accuracy as we go further up our scale. Now, before I can go higher, I need to change this to the 15 volt scale. See, that drops down, and on the 15 volt scale, we're spot on 5 volts. It's amazing. Again, this is either because I still need to, probably could polish those contacts a bit better, that can change this, or it's because of the resistors we chose. But anyways, 15 volt scale, let's get us up to 10. At 10 volts, we're seeing, let's see, 5, 6, 7, 8, 9, about 9.5 volts on our analog. Let's get up to 15. Essentially at 11, 12, 13, 14 volts here versus 15. We can go up to our 50 volt scale. And let's go up to 20. Okay. Back this off just a tad. Oh, too much. Okay. 20 volts on our digital. On the 50 volt scale, so we're down here. Seeing about 19 volts on our analog. And I think I max out at 30, so we'll just, with my digital, with my DC supply over here. So we'll bump it up to 30. Yeah, 31's the max. All right, we'll call that 30 volts. And we're seeing, let's see, 20, 25, 26, 7, 28 volts here on the analog. Yeah, the further we go down scale, the kind of the more accurate we get. The more we are on the left side of our scale, the more accurate we are than on the right side. But, not too shabby, I think. Is there room to improve? But, yeah, absolutely. But as far as, analog multimeter like this, given the age of it and everything, I think that's pretty remarkable that we have the accuracy that we have with this device. So in my head, I think that's pretty good. There are probably those of you who use older test equipment like this maybe still have some that are working. Put down in the comment section what you think. But yeah, again, you know, could be because of the resistors that we use to sub out the bad ones. That is probably a significant factor in it not being as accurate as our digital multimeter. Or it could also be that I probably need to spend a little more time polishing the contacts on our rotary switch. But that being said, let me drop this down to below 15 so we can decrease scale. All right, we're at 13. Go down one. You can see that the rotary switch works as it should now. Let's go below 5. And I'm pretty happy with that result. So let's check out our resistance measurements. We'll decrease it. All right, so that's roughly 7K sitting right there. All right, I'll disconnect it. Hopefully I haven't jostled it around too much. Yeah, roughly 7K. All right, let's check our leads here, get them zeroed out. All right, and am I seeing 7K with this guy? Yeah, we're well above that 500 point, so technically we should probably go up a scale. Disconnected. Hold on a second. Can I get this hanging up so it's not doing that again? Yeah, we're well above the 5K point. Let's bump it up to our 100K. And there we go. We can see that 7K. So, say that's fairly accurate. What if we get all the way up to the 1 meg range? So let's max this out. We'll put it right there. That's around. Should be around 60,000 ohms. Let's check it with the digital multimeter. See what we get there. Or excuse me, not 60,000. It's either 60 or 600. I'd have to verify. Yeah, 60,000. There you go. 60,000 ohms. So literally, your usable range is just 0 through 60. Everything is so congested up here at the top. I wouldn't really call that usable. Then you get 100, you see 200, you see 500. You really can't count that range up in there. But yeah, this is fairly accurate. On the ohm side of things, realize it's probably not the best demonstration in the world. Hopefully this came through pretty well on the glass, but yeah, that seems to be working. So the last test we're going to have to do is our AC measurement test. All right, so what I've done for a bit, just so you can understand what I was talking about a wee bit better as far as our making a resistive measurement. Really, on this glass here, the only true usable range for your ohms range is 0 to 200. So while we're on the 1 meg scale, even though 1 meg is all the way over here, well, you see you've got 500K here, 200K here, 100K here, and then that would be 60K. So that's essentially what I'm getting at concerning that. Making that that type of measurement. But yeah, that's you could say that it's a fairly wide range, but really concerning accuracy, the only thing that's usable is whatever's between our 200 to 0. And under test, it appeared to be fairly accurate, so I'm pretty happy with that. All right, for this test, we're going to do our AC test. Now, concerning the accuracy of DC and our resistive test, they weren't too far off. The AC test is going to be predominantly, it's going to address the rectifier that we built and whether or not I'm going to need to adjust the value of our resistors in there. And most likely that will be the case. Now, this is a true RMS multimeter. This might be measuring peak to peak. So if it is accurately measuring, this would potentially be a higher voltage than what this one is measuring if it's peak to peak instead of RMS. Again, I'd have to find a pamphlet somewhere and actually read into it, but for the general purposes of this video, we will at least see if the AC measurement works, and then at some point in the future I can play with the values of the rectifier and get this section more accurate. Again, because of the diodes we use, replacing the selenium rectifier, that's going to affect how our AC measurement is made. But anyways, we can go ahead and increase our variac here, and we're immediately showing an increase there. Now I'm getting 3 volts on RMS on my multimeter, but I'm only showing a volt here. We are on the 5-volt scale, so for AC that's going to be this upper red one. Swapped over to our other scale real quick. 20 volts AC should be here. That should be 15-volt scale will be the 1.5 right now. And I'm, about what? About 13 and a half volts is what it's showing instead of 20. So I should be pegging the scale right now, which I'm not doing. We'll increase this to 50-volt scale. I'll keep increasing. 30. It's 50 volts right there. But I'm measuring 30 here. And maybe if I put a 4K ohm resistor in there, that probably would change some things. Okay, so I ended up with a rectifier, the 2K resistors in it that we replaced in the previous video. I swapped them both out for 4.7K ohm resistors, and we're just going to compare the accuracy. Right now I've got about 2 volts RMS coming out of our variac here, and it's showing 1 volt on the meter, so we got a 1 volt deviation there, but we'll work our way through the scale to see if that accuracy increases. Let's get up to, see, not quite pegging yet, but essentially 6 volts gives us 4.5, so that's a 1.5 volt deviation. Let's go up our scale to 15. So on a 15 volt scale, we're down here, and we'll increase some more. That should be roughly 10 volts right there on the scale. So we see that we're still about a 1.5 volt off. Should be about 15 volts. And closer to 2 volts off there. Let's increase to 50 volt scale. So we're about 4 volts off on the, once we hit 20 volts here. Let's see, 30, yeah, I guess that's about 4 volts off. 40, and just under 4 volts difference. 50. Oh, we're at the top of the scale, so we need to increase. Let's go up to, let's see, let's go up to 100 volts. AC. Yeah, 100 volts AC, or about 6 volts, or at least on here, 100. That's 106 off there. 120. So, see, 100, 10, 20, 30, 136, 6 volts off. And we've maxed out our variac. Go to 500 volt scale, and about there at you know, showing a little over 100 volts. But so that's moving in the positive direction. Might swap them out for, what's the next resistors up? 4.7. I don't know. Might leave it here, might swap them out for just one more. Alright, so I went up one more value size in our rectifier from 4.7 to 5.6 k ohm resistors. And we'll do this test one more time. I think this is where we will probably end up leaving it. On the 5 volt scale, so that means that this upper scale right here, I'm currently showing 1 volt, 2 volt. So we're about a volt off at 1 volt. About a volt off. Let's go up to 3. It's mid-range on the scale. And about 1.2 volts off. So we're closing the gap a bit. Of course, 5 volts will increase the scale. So let's we're now on the bottom scale, so that should be 6 volts. We're 1.2 off. Let's get up to 10 volts. So 10 volts, we're still 1.2 off. Yeah, we're going to be 1.2 off through that scale. Increase up to the 50 volt scale. So let's see, 20 on here. About 22 on the digital multimeter. 22, 23. Let's get up to 30. Looks like we're starting to get more accuracy through our 30 volt scale. Now we're going the opposite direction. At 30 we're See. No, we weren't. My bad. 22, yeah, 1 volt off. At 30, 1.6. Let's get up to 40. And now we're starting to see the opposite effect here. We're about a volt off here. I mean, we're getting pretty close though. It was 45. You see the accuracy is definitely increasing. So about half a volt off at 45. Let's go to our 150 volt scale. And we'll get up to 100 volts AC. Yeah, we're bang on right there at 100 volts AC, pretty much. It's 100, and we're right there over the, hovering over the 1 here on the glass. So this is probably where we'll end up leaving it. And I can make a little deviation chart for myself so I know how far they're off depending on what part of the scale they're on. But yeah, that's about as close as we're going to get. So I think that's going to have to work. Now I just need to button everything up. Well, there we have it, folks. Restored functionality to this Triplett I-166 volt ohm meter. We have DC measurements back, resistive measurements back, and AC measurements back, and I couldn't be more happier with the restoration on this. Is it perfect? Absolutely not. Is it as accurate as I'd hope it would be? No, we lost that when we had to substitute out resistors. But can it work on my bench in a pinch? Absolutely. I think this thing came out rather nice. Interestingly enough, in the last video, got a couple comments. I think Alan Green, he mentioned that you know, concerning my confusion on the schematic, the 2M and what I meant. He said that you know, in French, 1,000 is milli, so that could be why the resistors are labeled M ohm. It's not for mega ohm, it's for milliohm, so that milli or whatever, so that could represent 2K, and that might very well be true. If anybody knows that for a fact, you know, you leave comments in the comment section and help educate us all. And then Ralph J was doing a bit of digging up of the name that we found inside the case here, that N. Peterson. And he said that pure supposition on his part, but there was a Lita Florence Triplett Peterson from 1900 to 1992 associated with Ray Triplett. So maybe a husband / sibling who signed the meter and was involved with the manufacturer. And again, I mean, if that's who that N. Peterson is, man, that's a marvelous story to tell concerning our volt ohm meter that we have here. So, like I said, I couldn't be any happier than what we have with this device. I'm glad to have this restoration done, and I'll probably just keep this one in my personal collection. We got to finish it out. We'll put the old schematic diagram back in there, wrap up my leads, and eventually I'll probably make some new leads for this, but not something I wanted to address for the content against this video. That might be to the ire of some of you, completely understandable, but that's just be the case with what I wanted to do with this. Regardless, that's going to be it for this restoration. Tell me, what would you do? Would you attempt to try to sell something like this, or would you end up keeping it for yourself? You can leave those comments down in the description. What would you have done differently than me? And then what should I have done differently? All those comments I enjoy reading. And by all means, if you're new to this channel and you've enjoyed this content, please consider subscribing. If you've enjoyed this restoration series itself, please give this video a thumbs up. But I think that's going to do it. We will close out this restoration. And as always, this has been Sean from Having Fun Repairs. I appreciate you've taken the time to watch. If you're in need of a vintage equipment that needs restoration or any repairs on any equipment, by all means, the business side of thing is down in the description below. That being said, take care, thank you for watching, and goodbye.
Mark?